Thank you. My name is Alexis Perez, and I'm going to talk about how essential it is to use Python in the under-the-hood operations of the UC Berkeley and UCSF supply chain management. And I will specifically be talking about an analysis that we do, which is monitoring pricing within supplier catalogs. So an overview of the presentation, I'm first going to give an introduction into what strategic sourcing is. I'm not sure if many of you have heard of it or understand what our purpose is, and then I'll discuss why, as a sort of administrative department, why we do choose to use Python for our analysis. I'll talk specifically about a routine analysis that is really essential to our operations, which is the Supplier Catalog Analysis, discuss some benefits and challenges that I have in dealing with the data, and touch base on a few other Python-driven projects that we're working on, and leave some time for questions and feedback. So what is strategic sourcing? Who are you? We are actually part of the UC Berkeley and UCSF supply chain management. The supply chain management is responsible for sort of combining both the UC Berkeley and UCSF purchasing power to give us more leverage in order to negotiate better deals with suppliers. So for instance, if we want to do a software deal with Symantec, if we only look at the UCSF Medical Center and do a deal based off of that usage, we're not going to get as big of a deal as if we combine UC Berkeley and UCSF. We also do some sort of system-wide, so we can take into account UCLA, UC Irvine. Essentially, the supply chain management wants to capitalize on all of the usage that we have within the universities, and strategic sourcing specifically deals with suppliers, maintaining contracts, doing negotiations either verbally, or we do hold reverse auctions. Reverse auctions are really interesting because it's sort of a real-time bidding event for suppliers based off of a certain lot of products. We just recently did a reverse auction for mini test prep kits. So we use the data based off of the spend to determine or predict what the annual usage would be, to give that to the suppliers, tell them these are the products of which you should give us pricing for, and then we watch how the suppliers give us lower and lower pricing, and then ultimately whoever does that lowest pricing within the allotted time will get that contract, and we will buy from them. So essentially all of the operations that strategic sourcing does is based off of our data-driven decisions from the spend data through our e-procurement system, which is Verified. So why do we, UC Berkeley and UCSF, strategic sourcing, use Python? It doesn't really seem a natural way to go about it, especially as Nick was talking about earlier today, how a lot of analysts choose to use Excel spreadsheets instead of Python for analysis. Well, we have a lot of data. It's not anything comparable to petabytes of data, but it is enough to become a pain in the ass if all of a sudden you want to do some sort of analysis. It accumulates every day. We need to manage it in a smart way. We need to be strategic about how we are going to analyze that data. And the data is actually pretty messy, and this is largely due to user input. So for example, if I'm going to purchase a computer, I could either purchase a computer through the e-procurement system and have and input it in a way where I just say the product description is computer, or I could just say it's MBP MacBook Pro 13, or etc. There's a lot of different variations on which the data can be input, and I'll go over that a little bit later. And so that's why our data is so messy. And just in general, Python is greater than Excel in a lot of different ways. It increases the efficiency of my time when I am doing analysis, especially routine analysis. I'm able to understand the data quicker, and there's just less time spent on this constant analysis. So that's why we choose to use it, and in fact, our UC Berkeley and UCSF strategic sourcing is trying to get other University of California strategic sourcing departments like UCLA, UC Irvine to start using Python, or to try to leverage our Python knowledge so the entire UC can actually become better when it comes to doing large data analysis. So the supplier catalog analysis, this thing is specific to my heart because when I started my job, I didn't know Python and I didn't know anything about this analysis. So my boss pretty much told me, so you need to learn Python and you need to code up this new analysis in Python. So I spent a lot of time trying to first understand what the catalog analysis even does. There's a lot of different aspects behind it, so I do want to discuss that. And then once I understood the analysis, I started to integrate Python and specifically pandas in order to make that process pretty much instant. So to understand the catalog analysis, it's essential to understand how people purchase. The reason behind why we want to understand how people purchase is because the different data comes in different variations based on how you purchase. What does the catalog analysis answer? So there's certain questions that will allow us to accept a proposed price file or reject a proposed price file. We'll go back to the supplier, tell them you need to work on the pricing, or it's just good to go. So it's good to understand those metrics. It's interesting also to take a look at the timeline of this catalog analysis. I just started a year ago, and before me, no one used Python for the analysis. So it's interesting to take a look at that timeline, so I'll discuss that as well. And just the whole process, what are we doing in terms of analyzing these catalogs? I want to talk about the benefits and some of the negatives of the data, and then the next steps with the catalog analysis. So if you're going to purchase something within the university, you could purchase it through Bearby, and this would be the web page. So for example, if I want to purchase pens, I would type in pens, and you notice there's actually 4,000 plus results. So there are so many different products that we have. The first 3 actually aren't even the pens that I wanted. So as a user, I would try to navigate my way through the system and get those ballpoint pens that I'm looking for. Now, going back to the first slide, there's different sort of categories. If you notice office supplies, books, we have different suppliers, and lab supplies, research, there's also different suppliers. I could either click on one of the icons to get products specific to that supplier, or if I do click on, for example, just based on my experience, I know that Apple has a punch-out. So their products are not hosted in our e-commerce system. I would have to go to their specific UC Berkeley, UCSF website for our products. And if I'm not going to purchase through the hosted catalog or through a punch-out catalog, I could enter a non-catalog form. So if I know that I want to purchase something and it does need to be paid through the university system, I could enter individually that product information. Now here in the red, this is actually where we get a lot of the messy data, because I could either enter that I'm purchasing a stapler, or I could just not enter anything at all. I could enter that I'm purchasing office supplies. So this is where most of the headache lies. Okay, so just giving another graph, how do people buy? So you could either buy through Bearby, which is that website, or you could buy outside of Bearby. We do have procurement cards, a credit card that would get paid through the system, but actually strategic sourcing doesn't see any of that data. So on our side, this is bad, because if I am trying to gather data to make a strategic decision on should we go with which supplier, if most of the spend through an outside supplier is not through the system, I'm falsely going to believe, oh, well, we don't purchase through that supplier at all, so we shouldn't move forward with them. There is not enough demand, when there could actually be a lot of demand. So within Bearby, though, there's 3 different ways to purchase. There's that hosted catalog, there's the punch-out catalog, like that Apple punch-out, and then there's the non-catalog form. Also within the punch-out and the non-catalog form, it's actually an uncontrolled environment. So we can tell Apple, hey, we want you to give us like a 10% discount for the university. But because they control their own products and their own pricing, we are unable to physically control that. We cannot block a product if it's too high. The best we can do is try to have more negotiations. For Apple, for example, University of California, Berkeley, and San Francisco is a really small part of their entire business, so they don't really tend to pay too much attention to us, which is kind of sad. But for the hosted catalog, we actually do have a lot of suppliers that host their products through our e-procurement system. So for example, we could have N different suppliers, and with all of the suppliers, I will be analyzing those prices. So there's actually millions of products to analyze for those. So the supplier catalog analysis, what does it answer? So it's a routine analysis. Every single time a supplier wants to update their product catalog, I will have to run this analysis, and I am able to determine if there are price increases or decreases, what products have been removed. This is really important because if a lot of our researchers like purchasing a certain product, product X, and then all of a sudden that's removed from a catalog, we don't want to necessarily accept it. So price increases are not the only thing to look at. And how much of the historical spend went through the catalog? This is a great question because if we notice that a supplier's catalog is not offering what most of our users are buying, we will want to do those negotiations so we can input those products into a catalog to make it easier for our end users. And then from the supplier catalog analysis, the file will either be approved or rejected. And I do send the results to an IT manager, so he'll tell me what to do. And taking a look at the evolution of the analytical process, so first, a long time ago, we just used Excel, and it was very time consuming. This was actually back in the day when Excel could only handle 65,000 lines. So if we had a product catalog that had up to 1 million lines, I'm not exactly sure how the analysts did that, but it was the runtime, it was their only job. So an analyst was employed just to analyze these price files. And it was very limiting, is prone to error. Next up, we did have a VBA script written. It was still prone to error. It was a bit buggy. It was not optimal, but at least it was faster than manual. And still, it took several hours to run an analysis on a large catalog. Before I came, everyone was doing VBA 2.0, where the bugs were removed, new metrics in terms of analyzing the catalogs were added, and this had been used for 2 years. It wasn't as bad as the first one, but it was still not optimal. And then I wrote the Python script, so we actually are using that currently. And I didn't add any new metrics, so I still wanted to look at price increases, decreases. If products were removed, I could look at the different pricing increases and decreases by manufacturer or product type. So I didn't add anything there. I pretty much just coded everything in Python. And we actually, through this, get extremely fast insight within a few seconds. And this is really great because we get that leveraging power in terms of negotiating with suppliers. So suppliers can come to us, say, we have a new product catalog, there's decreases, can you please accept? It makes us look a lot better if we go back within a few minutes and say, actually, there's not, we did analyze it, please fix the pricing. So the process for analyzing the catalogs, how exactly do we do it? So we do a naive forecast of the historical 12-month spend through that supplier, and then we combine both of the catalogs. So we have the current catalog and proposed catalog, and we only want to look at the products from which we have purchased. So if a current catalog has 1 million plus items, but we actually only purchase 10% of that consistently, those are the 10% that I'm trying to analyze. So I'll actually combine the current proposed catalog with our spend data based off of a created feature called part unit of measure. So it takes the manufacturer part number and the unit of measure into one, and then I want to merge on that. So I create a sort of a data frame in which I can get, this is a quick example, in which I can get the SKU, manufacturer number. I also have product description, UNSPSC, but I take the quantity and unit price from our spend data, and then I combine it with the current price, proposed price, and do some calculations based off of the historical spend. And if you noticed in this quick example that I wrote up, there is a product removed at the very bottom. So let's say this was the only products that we purchased through the catalog. That $15 or the total spend of $8,490 makes up the majority of that spend. So although there wasn't any significant price increases, here I would say, well, it's because most of the products have been removed, we don't want to accept this if this is if our end users have actually purchased a lot of that one product. And so other metrics that are analyzed, that was a quick example, I didn't go through everything, but we do look at the overall price change. Sometimes there are decreases, which is fine. Quantity of the products removed, again, this is essential. If someone was buying it, they and it was important to their research, we don't want to take that product away from them. We also look at the validity percent. Now what this is answering that question of how much of our spend goes through the catalog. If we have the majority of our spend not purchased through the catalog, we do want to, again, do those negotiations so the suppliers can add that in. And then in my report, I just look at price changes by manufacturer and by UNSPSC, so we can dig a little deeper into the data and understand exactly where those increases or decreases are going on. Now, the necessity for Python for this, why do I use Python to do the catalog analysis? Well, every single time a catalog is updated, and for some suppliers, they can actually give it to me more than once. They can give it to me a few times a week saying, oh, we made a mistake. I really need to, I don't want to take away potential price decreases if we have a limiting number of acceptances based on analysts' time to look at the catalog. So for example, there was this supplier who gave us multiple uploads of a product catalog because they had made mistakes, and actually the university was seeing price decreases. If we had not used Python, we would have just said, well, you already had your one upload, please don't submit anymore, and we would have lost that potential for savings. And at the beginning of each quarter, there's a large flow of all these catalogs coming through our system. So instead of having it be a burden on my time, I actually just run them all through the code, and instant visibility into what's going on. And again, as I mentioned, there are millions of products to be analyzed. Other benefits of using Python directly, so we are able to understand instant price increases or decreases, and until recently, we had not been logging the results of these price file changes. So if a supplier comes to us and they give us a new product catalog, if they say, now we're going to do an increase, no one actually remembered when their last increase was. It seems trivial to kind of store all the results in a log, but it hadn't been done. So now this code is just automates everything, so not only does it output the results, but it constantly just stores that in a log for really easy recall. If we ever need to look at a supplier's price file, we are able to understand what their history was. And then indirectly, this does give us leverage and negotiating power. It makes us look better if we can instantly see what's going on. We can understand the pricing impacts on research and education, and it just frees up my time to do other work. Now, pros and cons from the data. So at least because we are extracting the data from our e-procurement system, it is all in a consistent tabular format, so it's really good to use pandas with. And the spend data and then the catalog data, those are two different formats. One's a CSV, one's text. Still, it's really easy to use. There are minor column title differences, but it's trivial, so that's not a problem at all. There are the negatives, though. Because the non-hosted catalog forms is essentially a free-for-all, I can input a SKU number. I don't necessarily have to input a SKU number. I could input the product description, or I don't have to at all. I don't even necessarily have to put in a price. So this is really messy data, and the result of all this messy data is it actually is a loss for what I would want to analyze. And the next steps for the catalog analysis, I think this is great. We're going to be working on a new project. Instead of just looking at the proposed catalog pricing and saying, should I accept it or not based off of the current, I'm going to start creating, we're going to start creating a database of all the products that we already have and inputting the information from what the proposed catalog is and saying, even though the proposed catalog may be better in pricing to the current catalog, if we already have several products that are actually better, we don't necessarily want to accept that price file. So that's a next step for this analysis. And then quickly, other Python-driven projects that I find pretty interesting for strategic sourcing. Cherry picking bear buy. What would happen if every end user picked the cheapest product in terms of that's identical? So if we have pens that are offered by several different suppliers, if it's the same pen but just different prices, how much money would we save? Clustering departments by spend habits. So maybe the Department of Engineering always purchases off of an open tab or a blanket order. Just as well, maybe the Department of Art does that too. There's no really similarities, and other than how how their spend habits are. So we've done some of that analysis. And then discovering blanket purchase orders. So there's nothing in the data that will tell me this is an open tab or this is just a one-time buy. So we create some features and apply logistic regression to predict what exactly is a blanket first closed one-time buy. And yeah, so if there's any questions and feedback, and that's my contact information.